Alright, so today's lecture will be mostly driven by you. So we'll do a quick recap of the things we covered so far since the beginning of the semester. So we talk about Linux basic, how the file structure works. We talk about how to put in the commands. We also talk about how to write the scripts to automate a lot of things that you might want to do. Basically, if you want to be lazy and you want to automate everything, you can do that in using shell scripts. We talk about regular expression. Assignment one actually has a lot to do with that as well. We talk about Git and how to use the Git repo, how to kind of work together as a team on a shared code. And then we switch over to the basic C and then data types in C. We also talk about pointers and we talk about memory allocation, and both of these concepts used a lot in data structure. So these are the topics that would go into the first exam on next Monday. And as I said, I haven't got any email so far, but if you have lots of conflict on Monday, you need to let me know by, I would say, Friday. Otherwise, you are going to take the exam on Monday. So some of you asked me the question about, so what's the ratio between Linux versus C-based questions? And ultimately, this is between 60-40, so it'd be around more C related and less of the Linux related. For Linux, I just want to make sure you can use Linux, you can write scripts, you can actually do something that I might ask you to do on the scripts, which I'm going to show the previous exam from last semester a little bit here to give you some sample questions and see if you can kind of think through and work on it. But please keep in mind that these exam questions are 2 hours limit. And the last semester, I actually had 4 exams. So every time we switch a topic, we have a quiz. And that's a 2-hour quiz. So the Linux part would be 2 hours. The C part is also another 2 hours. In this case, the two combined would be a take-home exam, 24 hours. Probably about shorter, to be honest. As I said, you should be able to finish it within between 1 to 3 hours. It should not take longer than that. If it does take longer than that, it means that you might be doing something in a less intuitive way, or you run into bugs and you're spending time debugging, which is okay as well. So here, I'm going to talk a little bit about previous exam. I'm going to show you some examples. So here is quiz 1, which is on Linux. Do you see my PDF? All right, so it would be something similar, right? In the beginning, it would be something hopefully easy and straightforward. You see the questions, you should be able to describe what the command is doing. Otherwise, if it's error, you should be able to type in error. The problem here is I can't make it too simple because it's a take-home exam, which means that you can literally type this thing in, right? It would be a lot more design question where I give you a task and then you send the scripts back to me on a submission.sh file. So everything would be done in a file submission, and you zip it, and you give me that zip file that include all the questions. I'll make it clear in the instruction, but make sure you are familiar with these commands. I'm sure you use ls before. I'm sure you use copy, the cp command before. I'm sure you use echo before. SSH, which is this thing. Oops, I can't use the pen. Yeah, so the SSH command over here, make sure you know what it is. It's one of the things that if you have a server, but sadly everything is protected by this great Mahidol firewall where no one can break in. Basically, you need to make sure you know how SSH work. That might be the question on it. That might not be a question on that, but you should know. It is one of the most common command that you need to use in the future. You used cat command before, you used touch before. You've been using grep before, and grep also has a version work with regular expression. So if I tell you to, what does this do? You should be able to answer me that. If I want you to change the permission for certain directory in certain ways, you should be able to write a script to do exactly that. And then there might be some conceptual questions, something like this, right? So you see this program versus processes question, right? Uh, so what we would expect that you will be able to do is like, okay, if we give you these, you should be able to tell whether it's a program or a process. I might ask you to explain why you think it's a program or why you think it's a process based on that explanation. It was one of the downside of this particular version of the exam where I don't give you the room to explain why you circled that thing. Uh, some of these questions, if you interpret the actual question one way, you might give a different answer. So in the exam that's coming up next week, there'll be everything that you do, you can always explain what you're trying to do. And I'll give partial credit based on that, right? The more you explain it to me, generally that's better. Unless you explain it and it's clearly showing that, hey, you don't know what you're doing. In that case, I can't give you the grades. Again, this is the conceptual questions. And then here, let me scroll over. All right, so here now it will be a question of like, okay, give me a script that do this particular task. In your case, because it's a take-home exam that is a longer length, like between 1 to 3 hours, the question might be a little bit longer. There'll be fewer questions, but each question might be longer. It might be basically I'm going to prevent the case that you can go and Google and know exactly what we are trying to ask you to do. It has to be coming out from your own design. So for example, over here, basically the script would be change the permission into a certain thing that I say in the question. Right? I can ask you to do other tasks, anything that appears similar to the assignment, anything that is similar to some of the in-class exercise, those are fair game. And like basically additional type of scripts that built from the similar concept of what you ask you to do in the assignment, also fair game. Regarding assignment, don't forget it's due tonight. So if you haven't submitted, I think 8 of you still haven't submitted yet. If you still have questions, feel free to send me an email. I'll try to get back, but just be aware it's due tonight. If you use one token for the late days, then that's tomorrow. So yeah, for example, there's another question. I basically specifically said without using the tutor, ls, and find, what can we do? What can we actually find all these non-hidden files inside the folder? That's another possible question that I can ask you. And given the amount of time, and also you can consult Google, consult internet, consult any textbook, it will be a little bit more of the design coming from you. There can be also a question on regular expression. Over here, I might be asking you, what does this dot star mean? Here. Can someone tell me what dot star mean? Question B here. Yeah, it's a wildcard. So what does the term match? What's the difference between dot star and star? It's actually not current directory. This is in the context of regular expression. So yeah, so any character for at least one character long, right? Because dot means that it's any character. Star means that it's the wildcard 0 or more. So what about dot star dot dot plus? how many characters should be in there with the dot star dot dot plus. So the video of this slide will be posted by, I think should be by tonight. After I get the video, I'll process and put it on YouTube on the MUIC playlist, right? So I'm not gonna give you the actual PDF, but then you can kind of scroll through this question and you can actually check and Google and actually try it using the your own machine and see what it match. So these type of questions are fair game. Basically, I can ask you to say, write a regular expression that would search for anything that are coming from the MUIC domain, right? That are in the email format. What's supposed to be going into the email format? The at, right? It has to be at maybe mahidon.ac.th, right? So you need to make sure you have the regular expression that match that particular pattern plus whatever comes before the at sign. Right? So how can you write the regular expression just for that? Right? You can use the plus, which means that one or more letters. You can use dot star. That also works. You can then make sure that it ends with the mahidon.ac.th. How can you make sure the dot is the actual literal dot, not a wildcard? You can then use a backspace, right? A backslash, my bad. You can use a backslash dot to make sure that, hey, that's a literal dot, not a wildcard. All right, so this is kind of almost similar to one of the example in class, right? Can you find a regular expression that would give me a parse, like basically we go parse an HTML files and search only anything that matches image source equal in quotation, whatever the file is. So something like this can go on to the question that we asked you to do as well. All right. And then I don't think I'm going to ask you how to work with Git because going forward, I am going to make sure that you play with Git, right? So the assignment one is already like giving you the example how to do a pull request. Then assignment 2, 3, and 4, basically I would create a separate folder and making sure that all of you can now share the test code. And actually, I'll let you know right now. Basically, if you come up with a test that break your friend's code, you get extra credit. Basically, going forward, assignment 2, 3, and 4, keep coming up with creative tests. If those tests break your friend's submission, you get extra credit. And then because you push this test on the GitHub, right? Everyone has access to that, so you can always access it and test your own submission if it passed everything or not. If it doesn't pass that particular test, you can then look through like why does it fail. So there might not be a question on Git, and I said might with the asterisk. Basically 99% chance I'm not going to put that question there, but you need to make sure you know how to work with Git. All right. So let's take care of the Linux part. I can ask you to write scripts. I can ask you conceptual questions about, okay, what do I do? What does this particular command do? I can ask you, what does this particular regular expression match? Let's jump over to a C-based exam. This is in the previous semester. This will be the second exam. And keep in mind, this whole thing supposed to be done in 2 hours. I made a big accident last semester because the exam turns out to be, one of the questions turned out to be harder than I envisioned. So everyone did not finish. And then I curved a lot. But I'll tell you once we are at that point, and I'll let you know that it's not going to be as hard for that particular question because I was relying on the fact that you took data structure before and you know how to rotate a tree. Apparently, that's not true. So in this case, I'll take the note that not many of you have taken data structure class. Right? So anything that I ask you to do, it will be explained in detail. So, these kind of basic questions, you're supposed to be able to answer that. What if I do this? What do I get? So what is the difference between int a10 and then printf %d star in parentheses a plus 2 and this last one where I say star a plus 2? Can someone tell me the difference between these two questions? Exactly, yeah. So the first one, star in parentheses a plus 2, you get the third element of your array, or a2. Star a plus 2, you then first dereference a. You get a0, you add 2 to that, and you print it out, right? So these things should be your free points. Basically, you should be able to answer that. And in this case, you have the C compiler and you have the computer in front of you. So you can literally try to type it out and you can tell me what's the difference. All right. Then it will become more of an implementation question. So this question is not that bad. So basically we talk about linked list, right? Actually, let me open this in Microsoft Edge because I think it's easier. At least I can. At least I can make notes on there. All right, do you see my screen? And do you see like my marker that put on the exam? Okay, awesome. So now I can write things. So this is basically A2. This is A0 plus 2. Those are the two differences. This is essentially A0. What does this do? If we assume A is 65, what is what what do you get from the %d hello world? Any takers? Actually, it's the ASCII of the letter H. So it won't print the entire thing. Why is that the case? This is array of character, right? Which means that it's basically an array of H followed by letter E, followed by letter L, followed by letter L, right? And then so on and so forth. And here, because yes, actually, %d and hello world is a pointer. It's a pointer to an array of character. So this is almost the same as you first dereference, right? The pointer, which would give you the letter H, which if you print that in a number, it would, yes, so you get the ASCII number of the first character, which I think is 65 plus 7, if I'm not wrong, which is 72. If I'm not wrong, basically from A to H, that's 7 steps. Unless I fail math. But yeah, that should be it. 72, I think. And for this, basically it's print hello world. All right. The second question over here, I asked you how to implement a double linked list, assuming that this is my struct, right? This is the struct that I predefined for you, so you need to use this starter code. This is the pointer to the first and the last node on the linked list. And what is a double linked list? I kind of like explain it here, where basically in the linked list it's something like this, right? You have the pointer to the next node and then toward the end, which is nothing. Double linked list, and this is the head. Double linked list is you have the head. The head can point to the next element, and you have the two-way pointer. Basically, that can be the next and the previous elements. And then over here, you have the tail, which tell you as that's the last element. And then the pointer to the last element would be now. The pointer to the element before the first element in this case is supposed to be now as well. So what I ask you to do here is to first write a function that insert, right? Let's say I have this linked list. How can I insert new element? So how can I insert a new element to this linked list such that you have this updated linked list with one extra thing? And then I'll tell like, okay, if this insertion fail, you return one. No, if the insertion passed through, you return one. Otherwise, you return 0. What are the cases where insertion can fail? I basically give it to you. I basically say, if you call malloc and you got a now pointer, that insertion fail. Why does it fail? You don't have enough memory. Your DRAM is not enough to hold that one extra element. Input is the wrong type, that can fail too. That's a great answer. Basically, if you check the input type and it's wrong, you can then say, hey, insertion fail. But in this particular question, my assumption would be like, okay, if the insertion is cannot be allocated, then insertion would fail. The next question is kind of like almost a follow-up to the first question. Instead of insert anywhere inside my linked list, can I insert at the beginning? Basically, insert at the first element. In this case, what do you need to do? You then need to modify, right? Modify the head. Make sure the old head, the head with the previous equal this new element, new node. And then new node. Next would be the old head, the old head elements, right? This will go to the new node. Basically, this is how it works visually. This is the old linked list. And this is the head. What you need to do here is you then remove, not removing, but basically have this head point to one more element. So let me use the eraser here. So now head would point to this new element, right? We're now pointing to this new element. The next item for this new elements would point to here. The previous element, previous node of this old head would now point to this new one. And then the previous to this new one is now. And that's the only thing you have to do for insertion at the first. Right? That's it. I would then ask you to implement get value. Basically, it means that you have to traverse this linked list into that ends node. If the linked list doesn't contain that many elements, you return 0. Otherwise, return the value inside that node. I can ask you to get the node, right? Get a pointer to the node that points to that particular, like you go through and compare the values. If the value match, you return whatever the first element you found. And then I can make you create another list that maintain every single node that has the matching value. So instead of returning the first node, now you return a new list that contains every single node that has the value equal to the search value. Right? And here I can ask you to get sorted list, which means that you can use qsort. In this case, you can actually Google what qsort is doing. It takes a function pointer to a comparator, and that allows you to sort everything inside an array or a range of the items in a pointer, and you can get sorted list. So at this point, you might have realized it's a lot of things to ask in 2 hours, right? So this question is where I then realized this exam is too long. Your exam is not going to be probably not as long, but in this case, I ask you to manipulate the tree structure by do this rotation. You can rotate left or rotate right, and then I kind of like tell you how this would look visually. And then I didn't realize you did not take data structure, and those who take data structure, they did not cover how to do tree rotation. So that was my fault from the previous semester. I made sure I explain in detail. If I want you to do something, I'll explain in detail how that can be done. Your job is to translate my instruction into C code. All right. Basically, I'll tell you the instruction in human language. You translate into the C code. If you have any questions about my explanation, if it's during the first 2 hours of the exam where I'm still proctoring everyone, ask that question. If not, if you have a question after we finish the live session, then you can email me and ask the question afterward. If I think the question is basically, I would say not fair, basically I have to give you the answer to the exam, then I'll tell you I can't answer that. But if the question about like, can you clarify what this part means? I would try to do my best to clarify that. All right. So yeah, basically this question asks you to rotate left and right, and then the next set of questions I had from the previous semester is basically I already allocate an array, right? And then it's kind of like, okay, let's play around with this array. What if I do casting, but I cast it to different data type? What is the value that I would get? I'll put the code here so that it go into the recording. Here's the code. And down here are the questions. You can actually try this anywhere at home. Basically, you can write the code in, write this command and print it out. And some of this might run into errors. Some of this might run into seg fault, which is another form of errors. Some of this would actually give you value. If you try it out and you are not sure why certain things happens before the exam, send me an email. All right. Basically, you can say, okay, I put down this particular code right here, right here. And then you type in this, you expect the result to be certain value. But is that correct? Is it wrong? I thought it would be different, but when I print it out, it's a totally different value. What happened here? So these are some of the questions that I can ask you. This is like I cast it first as an in pointer, add 1200 to that pointer, which is a type integer. Then I pass it back to, okay, what's the value in that pointer? I dereference that pointer. And then I cast it unsigned char. What is the value I'm supposed to get? Well, first of all, unsigned char is between 0 to 255. So which byte am I pointing at after all this pointer arithmetic? Right. So go through this question. Let me erase my marker here so you can clearly see what is the question. And I'll go down slowly so you can have time to, when you watch the video, you have time to type in and check it out. And that's it. The rest are scratch pad. Okay. So these are the sample questions from the previous semester. And right now, your turn. Q&A. I have a bunch of blank PowerPoint slides here based on your question. I just want to draw it here for the answer. And this video will be posted. The slide will be posted. To be honest, but it's not a lot of content. Whatever you ask here would be annotated. I'll save the annotation. I'll post it on the class website. So, questions? Oh, we're gonna sit here being awkward in silence for a long time. 1.5 hours. How long is the exam? 24 hours. Okay, that's another question coming up is, can I explain about pointer casting and also recap on SSH? Let's do the pointer casting first because that was the first question that get pop up. So here, let's say each of this box is 1 byte. 1 byte block. Let's assume the following. Int is 2 bytes. Char is 1 byte. Long integer is 4 bytes, etc. All right. Let's assume this is the pointer p, which is int pointer. Where is p plus 2? Which one I'm gonna point at? And let's assume let's annotate this a little bit. So this is 0, box 1, box 2, box 3, box 4, box 5, box 6, 7, 8, 9, and 10. Which box is p plus 2? So how many box am I going to skip for each increment of an integer pointer? Because none of these answers are correct, actually, because integer is 2 bytes, right? This is 2 bytes for an integer. P plus 2, it means that I'm gonna go to 2 more integer elements, right? So this is basically P plus 1. And this would be P plus 2. Why is this the case? Because p plus 1, which is the second element of my integer array, has to be 2 bytes after the first element. It's just because the first element is large, right? It's 2 bytes, it's not 1 byte long, it takes 2 boxes. The next element would have to take 2 boxes. So this is the first element. This is the second element. And this is our third element. This would be our fourth element. So this would be p plus 3. All right. So what if I do this? I cast P to be a long pointer. Can I do this? Now, which box am I? And let's say Q equal. Which box is Q pointing? Eight. Yes, it's actually pointing at 8. So this is Q. Why is that the case? I changed the type. So this changed into a long, right? Long pointer. So every time you add 1 to this long pointer, it takes 4 boxes. And because you add that twice, because it's +2, right? It's 4 boxes followed by another 4 boxes. Then Q points to the next of the set of 4 boxes. So this entire thing is Q. It takes 4 bytes. And then, so what if I do star P +3? Which box am I? Yep, 3. So that should be pretty obvious. Now each box is one, like each pointer, each element in a pointer is 1 box long, so it's gonna point to the third one. Question. So what if I want to print that as an integer? I would let you actually try this out at home. You now have the pointer. You cast it back to integer star, my bad, integer star, right? So now it's a pointer of integer, and then you do printf. You dereference this whole thing, and then %d here. What will you get? Basically, I have this pointer point to the third box. Then you change the type into integer pointer, which would now cover which box? 3 and 4. Yeah. So if that whole 2 bytes, what will happen if I print those 2 bytes? One good way to test this on a computer is you can actually now initialize every single character here, right? Start from 0. So you can say this equals 0, this equal 1, like put the literal value 1, 2, 3, 4. And then when you print it out, you pair up the bits and see if this match what you think is should be. It actually print the value of box 3 and 4 concatenated together. It would print whatever this value represent, these 2 boxes. Right? Because we cast it back as an integer pointer, so it now covers the range of the third box and the fourth box. You put the 2 boxes together as one single number, and whatever value that represent, it get printed out. So whatever value that represent get printed out into your screen, right? So you check the value and hopefully it match with your expectation. Quick note, in GCC, integer doesn't have to always be 2 bytes. In a modern GCC, that is 4 bytes. So if you try it on your machine and you use GCC to compile, integer can be 4 bytes. The good way to test it is use size of, and then you just put in size of int, right? It would return how many bytes integer type takes. Let's say integer type takes 2 bytes is a MCC from back in the 90s. Then you get 2 bytes. If it's a modern day GCC, I think it's version 7 now, but the current version of GCC that can be 4 bytes. All right. right, so that's a question. That's a question about pointer arithmetic. So hopefully this gives you some overview of how it works. So let's go to SSH, right? SSH, generally the default input, you put in the IP address. This can be the actual IP. It would try to connect to whatever computer that is tied with that IP address and establish a secure connection. This SSH stands for secure shell. Basically, it's a shell that is secure. You can trust that whatever you communicate with that machine, no one can listen to it. Uh, nope. So my plan right now is not to post it on Canvas because I don't really want to distribute the PDF everywhere. But then the recording, this particular lecture recording, I intentionally scroll through the PDF. So you can look through the question and hit pause on YouTube and you can read the question. Right? So I hope that answer your questions. I won't post the actual PDF on Canvas because I don't want at the end of the day in the next like I don't know next 3 years this PDF get circle around among everyone here and I don't know yeah so just to be on the safer side you kind of need to go to the video and kind of like look at the question. Uh, So SSH, take a default input to be the IP address. You can do something like this. SSH. So let's say I have a username Rashada. So I can do Rashada at and then the IP. Right. So this can be at I don't know 171.0.12.164. It can be any IP address. If the machine, right, this machine has a username called Rashada, the next thing that SSH would do is it would basically ask for my password, which I would then type in. Once that's done, I get the terminal. Basically now then I'll get a terminal program. I can type in the command. It will be the command that run on this machine. One thing you can do with SSH is I can do -p. -p would say, I'm going to establish this secure shell through this port. Right? So if you specify the port that you want to connect to, by default, the port number is, so if you don't specify the port, like something like this, right? Then you connect to port 22. And why is this not great? So I've seen instances, for example, my machine when I was a student at CMU, my own machine would get flooded by SSH requests to port 22 because a lot of hackers knows that by default we use port 22. I then can change my default SSH port from 22 to something that I want. In that case, there's no way if they don't know that secret port, then they can't connect to my machine. I actually have friends' computer at my lab in CMU get hacked by someone because of this reason. They brute force port 22 with the I think with the username root, right? Because the root user is always going to be named root, so they will just guess what's the root password. So one way to prevent that is to change the port. So let's say I change the port of my SSH in the server to 12345, then I can do this. Add the same IP address, right? So basically this you have to know beforehand. This would be the username you want to log into. And then this would be the port that you want to connect SSH to. Uh, but that's not much it on how to use SSH. SSH. In Windows, you can use this thing called PuTTY, Putty. It's a program that allows you to SSH to a server. It would open a terminal, and you can type it in as if you have the terminal in Linux. I can actually show it to you. Actually, let me do that. So I have a PuTTY program right here. I can type in the. Okay, let me connect to this server. It would say ask me what's the username do I want to log in. If I don't specify the username, I would type in my username followed by the password. And notice that this is the IP address of the machine that sits somewhere in the world, right, that I want to log in. You see how it becomes a normal terminal? And if you somehow is in Mahidol University Wi-Fi or Ethernet, like the network, you can then log into Syskill, which is a server that we supposed to have for you, but now you can't log in because you're all at home. So I can write, basically I can then connect to the machine inside the Mahidol University and run things. And then I can type exit to get out. And now I'm back in the whatever program I'm at. Basically, it's just quit PuTTY. All right. Any questions? Any more questions? Can you explain about cons? Okay. Cons. Basically, it's been constant, right? So whatever is next to the keyword const, you as a programmer just said that variables will not be changed. So if that is paired to a pointer, it means that the pointer is not going to be changed. If that's paired to a typical data type, it means that the data's value are not going to be changed. That's the whole concept. Basically, it would then you need to kind of like see what is the word that come after const, and that becomes static. That basically will not get changed, and that's it. Yeah. Okay, so the another question is the difference between malloc and realloc. So stop with here. So what is a typical procedure if you have to perform a malloc? So what do you need to do when you do malloc? Let's say you have a pointer that point to somewhere, no, nothing in the universe. It doesn't really point to anywhere. Yep, basically then you do p equal malloc. Size of. This would make p point to basically a chunk of data. All right, so let's say I have more elements than what p can hold. What do I do? That's one way to do it. Basically, you run read alloc, which would give this basically the procedure of realloc is this. It would then have p point to something bigger based on the new size that you put in, and then it will transfer the data from here to here. The data get copied, right? So can you do that with malloc? Yes, exactly. You can do that manually. So realloc is like, okay, if I don't want to type in things in manually, I can realloc. But at the end of the day, this is almost like you have temp, right? Equal malloc, and then basically new size, right? And then you manually copy p into temp, right? And then you free p, and then you do p equal temp. And that's the process. Basically, you do this manually. You can use realloc for that as well. But quick note that when you call realloc, it's supposed to be on a pointer that you already allocated previously. Have any one of you seen this function? The function calloc. Yep, it's almost exactly as malloc. The difference is for calloc, your array would then initialize, everything would get initialized to 0. Malloc will not do that for you. So that's the difference. It would then initialize the space where every single item takes the value 0. So just want to make sure you are aware of like another super common function. Okay, so the question is, what's the difference between int store and int store? What is int store? So basically int store is something like this, where I have an array of int, right? It can be whatever size it is as a pointer. So that's int store. So hopefully that's clear. Let's say this, we call this pointer 1. Then you have another int store. It can be different size, actually. It can make it larger. This is pointer 2. And then, so this is int store. This is also still int store. I can have pointer 3. Okay, let me erase this. This is another int store, but it's a lot shorter. That's pointer 3. I can then create, right? I can then create an array that store all this pointer. So I can do int store. Basically, this is array of pointers, where you can have something like this, right? Pointer 1, pointer 2, pointer 3. And visually, what happened, pointer is basically point to some address location, right? So the value here would point to here. This would point to here. And this would point to here. And that's it. That's in store. You can then do in triple store, which let's say We call this pointer. I don't know. Give me some name. Can someone give me any name? Oh, I guess the first step is wake up first. All right, PTRA. Okay, I'll name this PTRA. I can have another pointer which contain PTR4, PTR5, PTR6, PTR7, right? And I call this PTRB. So both PTRA and B are the type int star star. I then can create another set of pointer that store PTRA and PTRB. Right? This would be of type int triple star, where this will point to here. This would then point to here. Sorry about the handwriting, and this the arrow just goes everywhere. So how can, okay, that's a great question. How can I get PTR1 from install store? Basically, PTR1 is already PTRA, the PTRA is already point to PTR1. So you can do the reference PTRA, you then get PTR1. If you want to get PTR2, you can do star PTRA in parentheses, right? Plus 1. This will give you PTR2. So how can I get, say, PTR6 from here? What do I type in? PTR6 is here. Yes, exactly. Star. Oh, my bad. You can type in star PTRB plus 2. All right, so a little bit of something more complicated. Let's say I name this, I don't know, temp. Right? Let's say I have temp. How can I go from temp to this element? From temp to the 1, 2, 3, 4, 5, 6, the 6 elements of PTR2. The first thing I need to do is, well, PTR2 is in PTRA, right? So the first thing I have to dereference so that I get PTRA. So I would do temp dereference, right? Which would get me here, Then from PTRA, I want to go to PTR2, so I can do plus 1, right? And then dereference that in order to get here. And then I can do plus how many? 1, 2, 3, 4, 5, plus 5. And then dereference again. Then I'll get to here. All right, basically, you look at the uppermost level and see, okay, in this boxes of pointers, which one points to the correct path? Right? So what if I want to get to the second element, right? Second element of PTR7. What do I do from temp? Basically, and then I'll do temp plus 1, right? And then the reference, because then you need PTRB, because 7 is in PTRB. Then you do plus 3, right? The reference, because this is plus 0 is here, plus 1 is here, plus 2 is here, plus 3 is here. From PTR7, how do I get to the second element? The first element is plus 0. The second element is plus 1. So I just add 1 and the references again. Now I would get to the second element of PTR7. And that would be an integer. So this is basically another like multiple dimension pointer arithmetics. If you have questions, draw something on a paper. That would be a lot more clear. Basically, at the initial, the last level where you have an array of, say, integer, array of character, array of something, then you build another array that contains every single one of these pointer. That's the second dimension. Then you can again build another. Okay, yeah. So for the homework question, okay. So let's catch that up after I explain this 3D array. Basically, for the third dimension of the array, then you can think of, okay, it's just an array of pointer that points to the other dimension of the array. All right. So is there a way to make arguments into a string? What do you mean by arguments? Is it argument into a function?
อาจารย์ครับ so in my vertical histogram, right, I create a function that taking a string and print the histogram.
All right.
In the question, อาจารย์ you say that you need, for example, the echo one ก็คือที่ผมเห็นคืออาจจะคือในตัวอย่างคือ pass คำเข้าไปเป็น argument นะ argument ใช่หรือเปล่าอาจารย์ตอนหลัง
เข้าไปเป็น argument หรือเปล่าตอนหลัง
เนี่ยอาจารย์ for example this one เนี่ยเดี๋ยวผม
Yeah, so you can share the screen actually if you want. Oh, okay. This is a test. Blah, blah, blah.
ที่อยู่ในโจทย์
Oh yeah. So that becomes the input to vertical histogram, right? And then in the int main, you can declare here AR star ARTC and ARGV. It will go into this pointer. Yep.
I don't know how to kind of use that with my function properly. I'm not sure how to use it.
ARGV0. That would give you that would give you the, actually it should be ARGV of 1 if I'm correct. Basically ARGV of 0 would equal to the dot slash word is, right? And then ARGV of 1 would then equal to this is a test dash hello Mississippi, and then yippee. That would be ARGB of 1. This would equal to 2. Basically, the length of 2, so you know where is the end of your array of arguments. The first argument would be the command name. The second argument would be the first argument inside the command. Then whatever argument that come afterward, it parts between additional white space that you put in. So you can just call ARGV of 1. you would get then this string. Does that answer your question?
ถ้าผมลองปริ้น F R A R G B 1ผมจะได้ไอ้ทั้งหมดเลยหรือเปล่าอาจารย์
You should get this. If I'm not wrong, so the only thing I'm not 100% sure is, does it include the actual command name? I think it does. So if you print FARGV of 1, this is what you get. If I'm correct. Otherwise, this is basically ARGV of 0. In the case that it doesn't actually take in the command name, but I think like 99% sure that this is in ARGV of 1.
ผมปริ้น AR GB of 1แล้วผมได้แค่คำว่า this เฉยๆอะอาจารย์คำว่า this คำเดียว หรือผมอาจจะใส่
Oh,
argument
okay, that is
ถู
a
กต้อง
good point because this whole thing is separated by a space bar, right? Every time there's a space bar or white space in the middle, you increment the argument count. So in that case, if that is your string that gets into the input, the word this would be in argv 1. The word is will be in argv 2. The word just the letter A will be in argv of 3. And then the word test would be in argv of 4. And the way you can actually get the entire thing, right, is you then need to take advantage of this argc. Argc call for argument count. So you would then first loop through, right, loop through the number of argument count so that you read as many as the arguments as you need.
and it is possible to like combine all that argument into one string.
I think I'm not 100% sure, but I think you might need to put in a quotation to the whole string that you're putting in echo. But I might be wrong. I might be wrong in the sense that it might just interpret that as an additional spacebar anyway. I'm not 100% sure on that.
Ah, ใช่ครับผมรอแล้วถ้าเกิดผมใช้ quotation มันก็จะเป็นอันเดียวกันหมด
So you got the entire sentence, right?
ครับถ้าเกิดใส่ quotation ถ้าไม่ใส่มันก็แยกคำหนึ่งเป็น
Yeah. Basically, put in a quotation would treat that whole sentence as one literal string. So that get put into the argv of 1.
แต่ใน example ในโจทย์อาจารย์ไม่ได้ใส่ quotation นะมันไม่มีเอา quotation ในเนี้ย
It's okay, my bad.
ผมก็เลยหาวิธี combine argument เป็นสตริงเดียวอยู่
Well, you can do this without the quotation too. Sorry about that. All right, any other questions? Is the exam going to be harder than the assignments? That's a really tough question to answer because some assignment questions are actually pretty hard and some are not that hard. So I would say it should be around the same difficulty, but the question should take less time. Basically, I know, I'm aware that you don't have 2 weeks or 3 weeks to work on the question. So the question will be something shorter, but it requires the same amount of tinkering to get the answer. So hopefully that answer your question. And to be honest, don't be scared too much because if it's too hard, if you taken my class before, I curve things and I generally curve it so that your grade go up. If that ended up being too hard, my goal is to make sure it's not too hard still. So keep that in mind. It will be sufficiently hard to test your knowledge, but hopefully the same difficulty as the assignments, but take less time. All right, so it seems there's no more questions. I would save the annotation on my slide and then I'll jump back to my desktop and wait maybe 5, 10, 15 more minutes in case anyone else has a question. But that's pretty much it for the review session. If you have any follow-up questions, I'll try to respond to my email as soon as I see your question. Save this. Okay, keep annotation.